Hello guys, myself Sudeep. I'm going to explain about the topic PRIM's algorithm for finding minimum cost of spanning tree. And my friend Suhan will explain about this PRIM's algorithm by implementing at Java code. So now what is PRIM's algorithm? PRIM's algorithm is a minimum spanning tree algorithm that takes graphs as input and finds the subset of the edges of that graph to form a tree that includes uh, very every vertex which has the minimum sum of weights among all the trees that can be formed from the graph. Next, how PRIM's algorithm works. Let us look at this. It falls under a class of algorithm called greedy algorithm that finds the local optimum in the hopes of finding a global optimum. We start from one vertex and keep adding edges with the lowest weight until we reach our goal. The steps for implementing PRIM's algorithm are as follows. First, to initialize the minimum spanning tree with a vertex chosen at random. Next, find all the edges that connect the vertex to tree to new vertices. Find the minimum and add it to the tree. And lastly, keep repeating the step 2 until we get a minimum spanning tree. So now let's take an example. This is a graph which contains a total number of 9 vertices, namely 0, 1, 2, 3, 4, 5, 6, 7, 8. Let's look at Prim's algorithm in this graph. Step 1. The set MST. Here MST set means minimum spanning tree set is initially empty and keep assigned to vertices are 0. Here INF refers to infinite, infi infinity, 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 infinity. So now pick the vertex with the minimum key value. So here we have 2, 4 and 8. The vertex 0 is fixed. Include it in a MST set. So MST set becomes 0 set. After including it to MST set, update key values of adjacent vertices. Adjacent vertices of 0 are 1, 1 and 7. The key values of 1 and 7 are updated as 4 and 8. The following subgraph shows the vertices and their key values. Only the vertices with finite key values are shown. The vertices include MST as shown in the green color here, as it is shown in green color. Next, step 2. Pick the vertex with the minimum key value and which is not already included in MST. Which means not in a MST, minimum spanning tree is set. The vertex 1 is picked and added to MST set. So MST set now becomes 0 and 1 in the following set. Update the key values of adjacent vertices of 1. The key value of vertices 2 become now 8. So here we can see here 1 and 0. These are 2 inside the set. Next, step 3. Step 3 which says the pick the vertex with a minimum key value and which is not already included in the MST, minimum spanning tree. We can either pick vertex 7 or vertex 2. Let vertex 7 is fixed, so the MST set now becomes 0, 1, 7. Update the key value of adjacent vertices of 7. The key value of vertex 6 and 8 becomes finite, 1 and which is nothing but a 1 and 7 respectively. So then comes the step 4. Pick the vertex. Pick the vertex with a minimum key value and not already included in MST. The vertex 6 is fixed. That's why this vertex is fixed. So MST now becomes 0, 1, 7, 6. Update the key values of adjacent vertices of 6. The key value of vertices 5 and 8 are now updated. Then comes, as we can do in the similar way as I said before, we can do with the same steps for finding the minimum value and assigning that edges. So the repeat the above steps until we met MSC set includes all the vertices of given graph. Finally, we get this following graph, which is nothing but 0, 1, 7, 6, 8, 2, 3, 5, 4. This is the final prims graph which we get. So the minimum cost adding all the cost weight is 28, which is nothing but the value of 4 plus 0 plus 8 plus 1 plus 2 plus 4 plus 2 plus 7, 9. So this is a small example for Prim's algorithm. So now the Java code implementation of Prim's algorithm will be explained by my friend Suhana. Thank you.
Hey everyone, hi there. My name is Suhan. I'll be explaining the program PRIMS algorithm. Okay, my partner is Sudeep. He'll be taking the theory part, and I'll be doing the code explanation. Okay, so as you can see, the code is just displayed on the screen over here. Please concentrate on that. Before going through the code, just go through the theory. What my friend and partner Sudeep has done very well. Yes, let's go to the code. Now we'll just import the function scanner. Okay, scanner contains all the input output in Java. Now we're naming the class as program 9. Now inside the main function, we'll just go to the main function. Inside the main function, now before going to the main function, what is Prim's algorithm? Prim's algorithm is an algorithm which is based on the principle of greedy method. Okay, and it is used to find the shortest distance from a single source vertex. If there are many vertices, we're considering one source vertex, and from that source vertex we're finding all the shortest distance to all the vertex. That is called as Prim's algorithm. Now we are now one second. Yes. Now consider this. Consider we are inputting a weighted matrix. Okay. Since we are using the two-dimensional array, a two-dimensional matrix, that is row and column. So we are using a two-dimensional array, that is 10, 10. So 10 rows and 10 columns. Now int ijk. Ijk are nothing but used for loop. N is number of vertices and S is source vertex. Minimum is nothing but it is used to store the minimum distance from a starting vertex from the source vertex to the ending vertex. Okay, where the source vertex is pointing. Now what is sum? Sum is something like total minimum. All the minimum distance added up will give the sum. U is nothing but the starting vertex, V is the ending vertex. Flag. Now flag is nothing but if flag is equal to 0, if flag condition is checked to check whether there exists a spanning tree or not. Okay. Now let us do a solution array. Let us input a solution array. Now consider this as a solution array. In solution array, okay, consider first everything will be equal to 0. In solution array, first everything will be equal to 0. Now let's go. Don't consider these things, and just explain these things later. Okay, I'll explain these things later. Yes, consider so much that right now we have a solution array, and we have 6 arrays. 6 array index. This is 0. This is also 0. Now, yes. Now let's go here. Now the user have to input the number of vertices, right? The user have to input the number of vertices. That is n. We are inputting the value of n. So scanner SC is equal to new scanner system.in. SC is nothing but an object to input, to fetch the input from the user. So if n is the variable, so n is equal to next int because n is we have declared n as an integer type, so we require next int, right? Yes. Now we have for loop. For I is equal to 1, I less than or equal to 1, I plus plus, solution of I is equal to 0. Since it is a array, we require a for loop to declare from starting to end. See, we have declared everything as 0, the same thing in the for loop. Okay. Now, see, the user have to input the weighted graph. Weighted graph contains row and column, so we require I and j, correct. Now all the values in weighted graph are integers, so next int. Now a user have to enter the source vertex, from which particular vertex the user requires the shortest distance to all the vertices that user have to input. That is nothing S. So solution of S is equal to 1. Okay, now solution of s is equal to 1. So starting, we are considering starting 1 is equal to 1. Okay, this is nothing but 1. Now k is equal to 1. So k is pointing here right now. Currently, k is pointing here. Yes, k is pointing there. And we have solution of I is yes. Yes, correct. Yes. Now, while k is less than or equal to n minus 1, what is k? We have declared 1. So n minus 1, n is 6, right? We have taken n as 6 over here. 1, 2, 3, 4, 5, 6. Now, k is less than n minus 1. 1 is less than 6, correct. Now, minimum is equal to 99. What is minimum is equal to 99 is actually, in the theory part, we take the distance from one vertex to other vertex. If it is not specified, we take it as infinity. But the thing is, in code, we cannot take it as infinity because we cannot declare infinity in the program. So we take it as 99, a largest two-digit number. Now we have I is equal to 1, j is, we have two for those where we assign I is equal to 1 and j is equal to 1. Now let us assign I is equal to 1. I'll just write down because of the mess. Yes. I is equal to 1 and j is equal to 1. Let me repeat. I is equal to 1 and j is equal to 1. Yes. Now here, if solution of I is equal to 1 and solution of j is equal to 0, let's check it. Now the thing is, I and j are both are equal to 1. So they are pointing to the first index itself. Now what is answer in first index? It is 1. So what is the condition over here? If I is equal to 1 and solution of j is equal to 0, I is equal to 1 is correct, but solution of j is equal to 0 is wrong. So it won't enter this loop itself. It won't enter this part itself. It will go out and directly go to solution of v is equal to 1. Now what is solution of v? V is nothing but j. Now it will go to j. Now even j becomes 1. Yes. Solution of v equals to 1. Sum is equal to sum plus minimum. You know what is sum? Sum is nothing but all the added answer of the minimum distance. K is equal to k plus 1. K will point to the next index. Now, if there exist u and v, we input in shortest distance from u and we use nothing but source. So, is nothing but the destination and the minimum result. Now let's go to the next thing. For I is equal to 1 and j is equal to 2. Since k plus plus, k is pointing to the second index. Okay. Solution of I is equal to 1. Solution of j is equal to. So I is nothing but 1. J is 2. J is 2 over here. Okay. J is 2. Okay. Now the condition is this is actually 0. Sorry, slight mistake. Yes. Because we never updated the solution of j, right? So it remains same. We updated the j, but we never updated solution of j, right? So now the thing is, a solution of I is equal to 1 and solution of j is equal to 0. Is the answer right? Let's see. Solution of I is equal to 1, correct, 1. What is j pointing to? J is currently pointing to 2. So solution of 2 is equal to 0, correct. So it will enter the inside. If I is not equal to j, correct. 1 is not equal to 2 and minimum is greater than w of I comma j. What is w of I comma j? Minimum is 99, we have declared over here. What is w of I comma j? If you have to see this weighted graph, w of I comma j is 1 comma 2. 1 comma 2. That is answer is 3. Is 99 greater than 3? Let me write over here. Yes, is 99 greater than 3? The answer is correct. So it will enter the loop. It will enter the statements inside the loop. So minimum is equal to w of I comma j. So minimum will become 3. You will become I. You will get the value of I. We will get the value of j. So you will get the I. You will get the value 1, and we will get the value 2. Right? Yes. Now we have updated the value of u and v. Now solution of v is equal to 1. So what happens? Solution of v is nothing but j. So it becomes 1. Now it becomes 1. Okay. Now that 2 becomes 1. Yes, this becomes 1. Correct. Yes, now this becomes 1. Now sum is equal to sum plus minimum, to add all the minimum answers, and k plus plus, we are just continuing the infinite while loop. This is nothing but one infinite while loop. Okay. Now let me continue after a while, because this recording will stop now. Now please concentrate. Yes, now where would we stop? We came to the infinite while loop, right? Infinite while loop. Now we are in infinite while loop, while k is less than or equal to n minus 1. Where will this continue to? This will continue till the condition becomes false. That is, k should become 6. So if k becomes 6, that is, k will enter here. This part, k will enter, right? If k becomes 6, this whole condition will be wrong. The conditions will be wrong, and it won't enter inside the loop. Now here system.out.println u plus v is equal to minimum. U is nothing but starting vertex, v is nothing but destination. If the minimum distance between them is minimum. That's all. Okay, this is the program. Now for I is equal to 1, I is less than or equal to an I plus plus, solution of I is equal to 0. Now did you notice something? As the k went on incrementing, the value of array index, the values inside the array went on incrementing, right? It from 0 it became 1 1 1 1 1. For all the traversed elements, it became 1 1 1 1, right? Same thing, if it is 0 0 0 0, like if it is never traversed at all, or the condition becomes false and it always goes out of the while loop, then the flag will be always equal to 1. So if flag equals to 1, then no spanning tree exists. There is no distance, there is no minimum distance from particular source vertex to other vertex. Now here, else, then the cost of minimum spanning tree is sum. Sum is the sum of all the minimum distance from particular vertex to the to all the vertex. Now look at this. I have taken this graph in consideration to draw that matrix. Okay. Now if you take starting vertex as the source vertex as A, we have to see the distance from A to B, A to C, A to F, A to E, A to D, everything. Okay, we have to see that. Now let us go for the output part. Number of vertices is 6. Now we have to enter the weighted graph. Weighted graph I entered from this. Okay, from this graph I entered the values inside the matrix. Yes, now what will I take the source vertex as? We'll take the source vertex as 1. If we take the source vertex as 1, we are finding the distance from 1, right? So 1 to 2 is 3, 2 to 3 is 1, 2 to 6 is 4, 6 to 5 is 2, 6 to 4 is 5. So the cost of minimum spanning tree is 15. So total cost is nothing but 15. Okay, this is the answer of this program. Now after considering all the vertices, the distance from source A will be simplified. Instead of this big graph, will be simplified to this small graph, that is A to B, B to C, B to F, F to E, F to D. This is the final answer of PRIM's algorithm. Thank you for watching. Hope you all understood and enjoyed it. Thank you.